Hey, so I don't know how many people are watching right now. Just kind of trying to get this set up real quick because I can't see it when I have the title screen up because I'm just that great at OBS. Let me get this one lined up too. One day I'll figure out how to actually use this software. So, anyways, yeah. So last time we were looking at the this VM from a little tiny challenge that was on Malware Tech's blog, and we wrote a small architecture, and this is what the lifted IL looked like. We never did really get the formatting correct on the assembly part of it, but you can kind of see this is what we ended up with. You can click those and like see things. So we didn't actually solve it last time, and so I wanted to kind of do something with that to begin with. And so what we're gonna do is use something that I have used before, which is what I call a visitor. And it's this little class right here. Might look a little confusing, but the general gist of it is that you call this visit function and you pass in an IL expression. And the IL expression is then checked for its name, and if that operation exists in this class that you have, you subclass this, then it will call that function with the that IL expression. If not, then it just returns none. So the thing that we're going to do here is we're going to write one that will solve the flag that we have in this encrypted in this little thing. So, and I guess I can kind of talk about why we can do this like visit thing on it, and that's mostly because an IL instruction looks something like, let's see, if we do, no, let's do a store. And the store is going to be a top level instruction, and it's going to have a couple of operands on it. You can actually find these in the, we'll go with low level IL for right now, but in the low level IL instruction class, if you come to source, you have this nice IL operations list, a dictionary, I guess. And you can see these are all the operations, and these are their operands. So you have the operand name and the type, and everything is kind of tree based. So you can have expressions as children of the top level expression. And so for like a store, which you could kind of see from when we were writing the lifter, let's see, we had a store right here. This was one child and this was the other child. And whoops, let's go back to here. We'll go back. So for that case, we had a dest. Oops, I think it's like this maybe. Can't remember my Yeah. All right. So that's going to be a li constant, because we were everything was just like constant locations and things. And then we'll have another constant over there. And that's going to be the source. And I believe actually this wasn't a, well, I think there were some constants where it just stored directly. But let's add in the constant value, which I believe, let's just say it was 1 for that one, and CC is 10. So then B has a constant operand that's going to be BC, and C has an operand, constant operand of 10. Now, if we wanted to, if say the store was actually storing something into 1, but it was loading from 10, then, or maybe it was loading from a register plus 10, then, no, let's just do the XOR. That would work. Let's say B is that one, so we want this one. We'd have an LL XOR there, and then have our this one was going to be, let's say, a reg, and right is going to be a const. So now we have C, and C is going to have a left and a right child, and then right is going to have its constant, which was CC. So you can kind of see now, if we're doing like a visitor, it's going to be traversing these. What we're going to do is recursively visit each of these. Okay, so we're going to copy this first and put it there. And I guess I'll make it easy and just do from binary ninja import everything. So then we need to actually inherit from it. And now we're ready to rock. So first thing, let's actually come over here. So if we're looking at these, if we want to, we can do the, now let's just do the low level IL. So first thing that we're going to want to do is this store. We've got our first instruction is a store that stores a constant. So we're going to need our store and our constant operands or operations. So we'll do a visit store, and here we're going to have a dest, which is going to be then recursively doing expression.dest, and dest is not one. Then we'll want to actually, we need to write the value to that location. So we're actually going to be kind of like writing an emulator type thing here. So let's go ahead and add a init here and add a view. And then we can do we really don't have to do this because nothing actually gets set in it. Oops. But I do it anyways. And then we'll do a self.view equals view, and we're gonna make a binary writer. And a binary reader. Oops. And these are just kind of helper objects that let us write and read a little easier. With the binary view, yes, I'm in Python 3. With a binary view, you can read and write, which I believe they might just be, those might just be wrappers of the writer and readers, but the writers and readers actually have the ability to do some seeking. You can kind of come here and look at these. And the other thing that these do is, like, you can actually specify endianness, and it has these methods here that allow you to write an integer as opposed to writing a sequence of bytes like binary view has to. So when you're wanting to do something and you actually are only writing small values, and you actually care about whether or not it's a little endian or something, you can just use one of these, specify exactly which endianness you want, pass in the integer. You don't have to worry about using struct or anything like that. So that's kind of nice. And so that's what we're going to be using today. So we then have our store. Forgot we need to get our dest as well, or source. And then if, let's switch this around, none not in dest and source to make sure both of them are valid. Then what we can do is we can take our binary writer and seek to dest, and then write, I think that's right. Oh, it's not going to come up for me. Okay. Source. And so we're going to write the source to dest. So now how do we get the dest and the source? Well, that is going to be where we have our LIL constant. And so that one is just going to be return expression constant. And there's another one that will just, I know it's going to come up at some point, so we'll just go ahead and handle it as well, is expressed constant pointer. Sometimes, even though you didn't lift to a constant pointer, it will decide that you actually need a constant pointer, and so we're gonna just handle that so I don't have to deal with it later. So if we save this, and we'll go ahead and put it in here. You can see all my other stuff that I have. Whoops. All right. So got that. Let's go to Binary Ninja, and let's see, system path. Should have done this before. I'll put it in up 3. So let's see, that was VMArch. All right, so we should be able to import VM visitor. All right, and then let's see what happens if we do, oops, so hex. All right, so the first, let's do VM visitor VM visit. Can't type today. So this should give us our, whoop. Oh, whoops. That was dumb. Should have caught that. All right. All right, from import lib, import reload, and then VM visitor equals. All right, let's try it again. Okay, now we should have a BW, yep, and a binary writer. All right, and then we want, let's just check the first instruction and see what happens. So v.visit, make sure it's, let's just write it there. Oh, I think you changed this to LIL recently. Let's do the first instruction and see what happens. Nope, because I typed something wrong again. Should have seen this. All right. Reload that. I really should start doing this in a, actually, you know what? Maybe I can. Give me just a second. All right. We're going to make a Jupyter notebook. All right. Let's get this and take that, copy it. Sorry, I forgot to copy this file into there first. Okay, cool. The RAM is there. Okay, so let's go ahead and create a new one. And let's see. Let's see. Although actually I could probably just import from here, can't I? Let's try that. Since it's in this. Yay! Looks like that worked. Or did it? There we go. Okay, yes. So it does work. Okay, so binary view type, get view of file, RAM bin. Okay, so VM visitor, oh wait, bv.create user function, And I believe we need platform VMArch. Think that'll do it. Nope. What? Oh, because it's a raw. That's not gonna work. So I just need to do a standard binary view.open. Okay, cool. So now we should have some functions. Yes. Okay, so let's do a all right, so now we can do VM visitor. And we don't have to actually do the reload thing anymore. So let's try a let's try a read real quick and see what we get. So we got 0. Wait, is that the first instruction? Where are we reading to first? 1D. So let's read 1D first. All right, so it's still 0, you know. Anyways, so now we do a va.visit, vv.get function. Actually, let me just do functions because I know there's only one. That should be all right. So now if we come back and read this, oh, look at that. Now there's a byte written in the thing. So let's try, let's write a another. Oops. Oh. Python 3. There we go. Okay. So that's also not what I wanted to write. This is what I wanted to write. Okay. So we got that fixed. So now let's try for IL in range. And actually, we don't have any control flow, but we could. Actually, no, let's just do, this is all we need to do. Because they'll be in order. All right. Let's see what happens. Oh, because it's a check. Okay. And I don't need that either. That's what I want anyways. Oh my gosh. Okay. So we've got that. Now let's see what we've got for from 0 to for 16 bytes. All right. Look at that. Let me see. Yeah, so we've got a lot of bytes there that have been written. Now, if we restart this, now eventually it's going to stop. And let's do it like this. If il.operation does not equal let's restart clear output. All right. Oops. We don't need that one. All right. Let's also do a okay, so we did the first 32 instructions. So now let's see what so okay, so now we're at a register being saved, being read from a load. So now we need to deal with load and we need to deal with set reg. So let's do those. Oh, hey. So where are we? So now we need to do a set reg. And so then that's going to be what's our let's go see what our operations are on that. I think it's just source and dest. Set reg, yeah, so dest and source. And source is an expression, so we need to visit that one. And dest is just going to be the reg. Oh, I guess that's the other thing that we need is we need to actually track the registers that we're using. So let's do that. Because right now we don't have anything for that. All right, so we've got a dictionary of our registers. So dest is going to be expression.dest, and I think that's going to be a name, because I believe that here when it's a register, it's going to be an IL register. So let's try that. And so that's going to be self.regs. No, that's not what we want. We'll do that in a second. All right, and then the source is going to just be, again, self.visit expression.source. And if source is not none, then we're here is we're going to do self.regs dest equals source. Simple. And we need load. And so then this one's going to have just a source. And so we're going to do self.visit expression.source, because this could be a constant, or it could be a register, or it could be a register plus something, although in our really simple VM here, it's not going to be that complicated, but we still need to handle that. Then here we're going to return but we need to do self.binaryRead reader seek to source, and then we're going to return binary reader.read 8. And I don't think there's a thing on that. Oh, I know why I'm not getting my, doesn't do it if I'm not actually specifying the things. I think that's all the ones I need. Yeah. So now we've got all of those. Let's go back to our thing and we'll restart. Actually, no. We can just rerun this again. And yeah. Oh, gotta take that out. All right, so that's gonna run over everything. But I think we're still not done because we haven't done the XOR and something else. But I think maybe, yeah, let's go do, well, let's say if il.operation not in low level il operation dot lil store or low level il operation dot lil set reg. Oops, that's not what I wanted. Break. So just for oh yes, so I think we've done everything except for the XOR. So let's go ahead and add the XOR, and then we can just come straight back to Binary Ninja because we'll be able to see what we're actually doing. So I think the last one that we need is il XOR. And this one's pretty easy, although they're all pretty easy. So we have a left operand, a right operand, and then check to make sure neither of those are none, and we just return left XOR right. And fix that error because I know that's gonna be an issue. Let's come back here. Let's make sure I haven't, yeah, everything's good. So let's do a VM visitor equals reload, VM visitor. And this time, let's come in here. Let's see, where's my regular assembly? Right here. No, let's do this one. Let's see what happens. v.for il in bv.l instructions, and then we're going to do b.visit il, and let's see. what happens? Oh, look. That doesn't look right. Are we missing one still? Here, what we can do. Come here. Oops, that is not C. All right, let's see what we have here. If we, can I just null this out? No, there's no transform for just zeros. Oh, actually the 20s there are all probably messed up. Why don't I just reopen this and make sure it's correct? Whoops. Okay, yeah. Okay, so it looks like it's doing everything. Now, what am I messing up? Oh, I'm silly. There is one left that we have not done. And that is reg. So that's going to be an issue. So that's going to be expression.source, because source is, it's just going to have the source operand, and that's going to be its IL register. And we need to return source, no, self.regs, source.name, and let's see. I wonder why it's not throwing any. Oh, it's because it wasn't visiting it, so it was just doing none and bailing. So close that again, make sure we are good, and let's do it again. Do a lot of reloading. Oh no, that's not gonna work. I don't want to do that. What was that weird noise? That was strange. No, I don't know. Oh well. It was like this little ding thing that I have no idea where it came from. I assumed it was Twitch, but it doesn't look like anything happened on there. Doesn't look like anything's going on there either. So, okay. And let's see what happens when we do it this time. Not a thing. What is going on? I'm very confused now. What am I missing? I don't see anything wrong. So why did that? Oh, because I reopened it. And I need to create a function. So there were no IL instructions. So that was pretty silly of me. Oh, what are we missing? Guess it would be better if I put a name here instead. Oh, it was the halt, the no return. That's why it stopped. And look at that, we have our nice flag right there. Ah, that kind of was a little anticlimactic there. Thought I was messed up and I hadn't. Yeah, so we could just do something like def visit file no ret, I think it's called. And oh, no, I'd have to reload this. So we do that one more time, and then, oops, because I have to make the function. Making all sorts of mistakes today, huh? Oh, yeah, then it gets some nice output there. So cool. All right. So now the other thing is, I wonder, I may actually not get time to go to the obfuscation thing today. I'm wondering if we could actually make this work without having to do any sort of emulation, if the data flow itself can do it. And I think there's a way that we could actually do that. It would be a little janky though. But we could do something like, if we switch these to all being registers, instead of being writing to memory, then we could read in all of the memory into temp registers. It'll look really weird if we do this. Whoops. So I think we could do this pretty quick. So what we would do is first, when we come in here, let me see if I can, the length of this. We're going to do something kind of hackish. All right, so gonna come back to, I opened a bunch of random stuff today. All right, so we're gonna come back here and let's look at the log. Oh, did I not save it? I did save it. Oh, right, because it's the architecture and I haven't actually used it yet. So let's come here. Gotta remember where my bytecode was. Oh, I should have made a data renderer for this. So starting here, make a function. Okay. So we've got that. And we've got a nice little output of how many instructions, what our instruction index is. It looks like. So we're going to do something really janky, which is if len il equals 0, which I believe it does when we first come in, yes, then we are going to do a for I in, let's see, no, I have to read the memory. Can I do that? No, because I would be at the first instruction and I wouldn't get anything behind it. Yeah, I can't read. I'd have to do some weird, really janky stuff to read the memory. So, nope, never mind. I can't do this. We'll just cut this in post. So, yeah, because the issue is going to be that I can't actually read the values that are in this location. I could only set, I can set everything to 0 if I wanted. Up to right there. But I can't set these without knowing what they are. If I set those manually, then I could do it and have everything as registers, and then the data flow would just solve it for us, and we'd be able to just query what this is right here, each of these registers, and get the flag out. But yeah, so I can't really do that. So I guess we'll just move on to playing with something else. So something I was looking at, if I can find it now, is, so this is a obfuscated binary from, I think it's called plock. Yeah, plock. And I'm not gonna have time to play with it all today, so we'll probably start on it next time. But they have this obfuscator thing that's supposed to like obfuscate your stuff like super hard or something like that. I don't even know. I guess here's a nice little list of all the different things that it will do. And this is the obfuscated version. This is what it looks like if you pull it up into Binary Ninja. So we're going to kind of figure out what's going on here. And so right away, if we look at this, there's not much. You see a random push instruction and then a push FD for some reason, a pop FD, and then right in the middle there's a sub, and then a return. Now, the interesting thing here is you'll notice at the return here, it says var4, not return address. And that's because they've pushed an address onto the stack and then done something to it and returned. But you'll also notice here in the annotation that Binary Ninja knows where it's supposed to, what that value is. So we can actually get we can get that value very easily with a get stack contents at. And so I believe that's going to be here. The offset is going to be -4. And actually it's going to be, yeah, stack offset is going to be 4 from the start. And then we want 4 bytes. So let's make sure we've highlighted here. And let's do a, actually let's do a log info. Whoops. Forgot. That's a register value, so we want value. Oh my gosh. There's a reason why I'm trying to do it like this instead of just a simple print, but maybe I should have just done the simple print. The reason why I did that was because they now have clickable links in the log, so we can just click here and say, oh, okay, that's where it's going to jump to. So we can actually come back here, and I think we might be able to just do something really simple like current function dot set user indirect branches here, and then I think it's a list of architecture. Let's go look it up just in case. Because I think the nice thing is that returns have a branch info, and so that means that they're susceptible to having indirect branches added to them. So set user indirect branches. Branches. Branch.arch. Okay, so it's architecture and then address. So we can just do this. And we'll take this here. Put it right there. Oops. Now let's see. Oh, look at that. We have more control flow. And if we look at that in theme level IL, let's see, which one am I in right now? we still don't have anything that's actually of interest because dead code elimination or dead store elimination removes everything. So you can tell that ECX means absolutely nothing right now. And now we have a really easy one that's just a quick push and return. So we can literally do the same thing here. Oops. Ugh. Register has no value. Okay, let's see what we got here. Does it not see it now? I wonder if something got messed up with the stack. Oh my gosh. Why are you not? The console is driving me crazy right now. Undetermined. Okay, so now we've got something interesting going on. Let's look, because I've done this before and it shouldn't. Oh, it's because of the push FD and everything. So, you know what? Instead, we're just going to come here and let's do a bb.write here, bb.assemble jump. Oh, actually, let's just do a format string. Function dot. Oh, what was I doing? Get stack contents at here -4 dot value. Let's see. I think that might do it. Do I have all of my? One more. Nope. Arch. Oops. Let's undo that. One thing I forgot is when you're assembling, you need to remember to tell it where you are. When you're writing it, because otherwise you're going to get this weird address that's relative to 0, and so that was kind of the problem. Yeah, okay, look at that. We've got it created a function there apparently when we did the indirect branch. That's interesting. Huh. I like that. But I actually want to remove this function. Do I need to go into? No. Where's the remove function? Nope, it's not going to let me remove it here. Undefined current function. That's what I want. Okay. So now we've got our jump here. Oh, I'm in low lifted. Yeah, so now we jump from there to here, and now we've got this nice new one here, and this one's pretty obvious, so I'll just change it. Oh, that made another function. Huh. Interesting that it makes a function when you try to jump to it. It's turning them into tail calls, which I guess is kind of nice. So we have another XOR here, another push. This one looks exactly the same. So you can basically automate this to do this. See, here's the actual address that it's going to be. Here we go. Okay. So we'll go back and automate that next time, I think. I'm not going to have time to do all the automation this time. But this one is interesting in that we've got some actual conditional here. But what's it actually... What's it actually related to? And this is, I guess we need to get rid of these functions for that. Okay, so now we have a little bit nicer, easier looking thing. So this is what I'm more used to seeing. So you have a couple of jumps here. Your ECX is an undetermined value. We don't really care what it is right now. But then you see this jump here, and you have jump if equal, that it jumps down here, and a jump if not equal, if it jumps right here, and it'll jump here. So if you look at this, you can actually tell this spot right here is never actually going to be jumped to, because it gets here if it's not equal, but then it has this jump with no flag change here. And this is always going to be either true or false, and this one is always going to be the opposite of that. So if it comes here, then it's definitely going to jump to here. If it comes here, then it's never going to come here. So you can actually turn this into a jump. And we'll delete this function again. Actually, I think I can turn off something about tail. Yeah. I don't know if I have to restart for that one. No, okay. So let's see what happens next time. All right, so we got another one. So you can see like these are all pretty pretty standard. And so I think this is what we're going to play with next time. Yeah, there we go. Turning off that keeps the tail call analysis from happening. So now you can see there's another one. There's a jump if above comes there. And this jump, this one's an interesting one. So we've got a jump above. They'll go here. Let's explore this one and see what happens. Aha, yeah. So there's a jump above and then a jump below, and then it'll come here. So yeah, I think I don't have too much more time, so I think next time maybe we'll do this. But maybe we can automate one real quick. Let me see. What if we do the let's close this and redo it so it's all nice and clean. Oh, nice. It got rid of that one tail call there as well. So if we come here and we have a return here, we know that we want to get rid of this whole thing because you can see that it does this whole push and pop, because it does this to save the flags so that when it does this sub, it doesn't mess up any of its other flags that it might actually need for the actual operation of the program. So we can get rid of this entire basic block. So yeah, let's see. If we do we want to, let's see, can we use map to medium level layout? This is we do that gets us a sub. Ooh, that's an idea. So let's do a new folder. Oh, that before. So close these. I don't want to save that. All right. Remove that and no, let's not do a plugin. So we'll start like this. Let's call it unret. So we're going to do the last instruction of a basic block. Yeah, let's do a basic block. Just call it BB. So if we take this and we want to get the ret, it's going to be the last instruction. So BBC. That gets us the assembly though. Oh, I know. bb.end -1 is the return address, because we know it's just going to be a single thing. Let's see. Oh, we built this in here for now. So ret address is going to be current basic block dot end -1. Is that right? Oh, wish I could change it to display only the hex version. So we've got that. It's weird. I think this is a bug with the data flow that says here undetermined value, but here it clearly knows the value of that stack value. So, because it knows it's here, but then after the pop FD, suddenly it's undetermined and nothing else has happened. So I feel like I need to report that one. That's going to be our bug for episode 4. Is this is undetermined, and it should not be. So we've got a return address. So we want to say get our current stack. Let's see. Next jump is going to be current at ret address. I'm going to do -4, 4. Actually, we want current function dot think. There's a function I think that does the current stack frame. Maybe not. Because I need to know what the current offset is. So let's do I know. Get reg value. Reg value at here, and we want ESP. I think this is value, and then we want size 4. Nope. Offset maybe? Yep. Okay. So actually we want dot value here, maybe. Nope. Oh, dot value. Well, we want to say next jump dot that, and then we want to say next jump dot type is constant. So let's take some of that stuff and write it down. Here we're going to turn this to I wonder if I can do some see. Is that how type things work? Can I remember it? Nope. Oops. All right. And our address is that. And then just take this off right here. All right. Next jump dot type equals register value dot constant value. I think that's right. Yeah. Then next jump address. My tummy's growling. I don't know if y'all can hear that on the camera or not, or mic, I guess. So, all right, so we got that. So let's go ahead and save this. Oh, I put the folder in here. I'll fix that in a second. Yeah, all right, cool. All right, so we've got that. So first, step 1, find the return. Step 2, calculate the address to jump to. Why are you angry at me? Oh, current function. And here also, that's going to be the header. All right, so got that. Now step 3 is going to be a little bit harder. Identify the start. All right, so here is the issue. Is now we've got to get from here to here. So we need to, oh, this is probably actually pretty easy. If we let's move this to here. So we need a jump variable, and let's make that a variable. Let's see, so our function is function, our source type is going to be variable source type. I think we want stack variable source type, yep. Oh, there you go. What do I need? Oh my gosh, tell me. There you go, index. I don't remember what index is. So, oh, I think that's going to be our current ESP. And then storage is going to be 4, I think. Is that what the index is? Now I don't know. Let's see, current function dot vars All right. What is index? Index is 0. What is index? Index is 0. All right. Well, in that case, I think our index is going to be 0. And then storage is going to be right there. So let's see what happens when we do this. Oh. This would be a -4. And this would be a current function. There we go. Okay, cool. That's exactly what we want. So we have our jump variable. So now we want to get what am I doing? I need the API. So I want to find all the uses of this one. And I can't remember if function itself has this on it. So I want to get so this one doesn't have it. So we need to go to low level IL. No, we need to go to medium level IL. And actually, we're going to do something very interesting. Instead of using regular medium level IL, we're going to use mapped medium level IL, because mapped medium level IL is not optimized. And I don't want, and if you remember, if we go here, there's nothing. So what we're going to do is we're going to use this hidden version that you have to go to preferences and do enable plugin development debugging mode. And once you've got that turned on, you can come here and you can get the mapped medium level IL. And you can see you get your nice variables still, even though look at that. Now it remembers. What do you know? But it's just mapped medium level IL that it remembers it. Very interesting. Anyways, so what I want to do here is current. I think I can do. No. So I need current low level IL. Although, can I do current function? No. Okay, so I have to go through the low level IL to get to it. So now I can get var defs, I believe. Nope. Missions? Yes. Okay. And get our variable up here. Call it jump var. And then we can do a jump var here. So now we have a 1 and a 5. So those are in our current basic block. And we want to go back. We want the 1. We know we want the 1. But there's also the case in which there's not a subtraction here. So let's see. We want to then first identify whether or not we're in our basic block, which means that we're going to have to do a 1.address and a 5.address. And I don't think I can do this. Yeah, I can't do that, unfortunately. Although it's current basic flux still. I wish I could though, yeah. So you have to do yes, okay, so that's better. And I love being able to do this in Python, it's so great. So now if we do we've got our jump variable, we want to then do function mapped medium level IL equals function dot low level IL dot mapped medium level IL dot get var definitions. And I guess the question is, do we want to do the var definitions? Let's do the SSA var definitions. And that means that we need to turn this into an SSA var. That means that we need to figure out where that actually becomes what version it's actually at the time. This way we don't get a bunch of different definitions and have to figure out what they are. We can just track through them real quick. So jump variable SSA equals SSA variable, and it's then medium level IL get SSA var version, I think, yeah. Oops. Okay, where's the version one? Is it on the instruction? Sometimes this happens. It's hard to keep track of where things are. Instruction. Yes, get SSA var version. Okay, so that's what I want, and that's so I need to do this. Right, IL equals medium level IL. So we have the return at IL is the mapped medium level IL instruction. And then we can do jump variable, and this should tell us where get us the version, SSA version of that. So if we come here and do a ret IL equals I'll just do it here. All right, so we've got our return jump var4, and then we want to do an SSA version of jump variable. Did I just assign that up here? I don't think I did. Yeah. All right. There we go. Okay, so we know we're at version 2. If we come into mapped medium level IL, yep, var4 version 2. So now we can just do a, let me do my, all right, if we do a medium level IL dot get var SSA var definition of this, we get a 5. So that tells us that it's this address. Now, if we do a medium level IL5 dot operation, that is a set var, and then let's look at the source operation. That is not a constant. So let's look at the left, so var4. We can do the SSA form here, so we don't have to keep querying for the variables. Actually, that's even simpler. I'll go back for just a second. I don't have to do the SSA variable jump variable thing. I can just do il SSA form dot dest. Sorry for the loud clap. Yeah, so that's a lot easier. So let's just do that. I don't need jump variable. We got that, and I don't need this. I can just do ret il SSA dot dest. Whoa, no, I don't want that. All right, so now so let's do il equals il of all right, so that will give us the il instruction. Let's say while il dot source does not equal, oops, I think that's going to be a constant. Yeah, cool. So while it's not a constant, then we will look at we'll just assume that it's going to be some sort of mathematical operation, and then the variable is going to be on the left. So we'll just make a quick assumption here. We'll say IL equals IL All right, let's see what happens if we do this. Oops. All right. Nope. No attribute var. What did I? Oh. That should actually be yeah. Okay, so now IL is that, and let's sort those. All right, so we've got that. Let's see what happens if we do this. Oops. Can I do a shift? No. Are you kidding me? Oh, I did the same thing. All right, there we go. So found it. Whew, lots of typos. Thanks, Stormcorp. Have a good night. I feel like I can't win with my time zones because I do it early, then EU is going to sleep, I guess, and if I do it late, then everybody's asleep. So that's kind of, being in the Pacific time zone is kind of a bummer for streaming, I guess. So now that we've got our start, this is where we're gonna patch the binary jump. So our patch address is going to be il.address, and then we're going to do a, let's say view equals function.view, right, and this is where we're going to do a view.assemble, oops, arch, oh wait, no, patch address, view.arch.assemble, and then we will do a jump ox. See, where's our value? Next jump address. And then we do a patch address here so that it knows where we are currently. Here, put some. I'm gonna just do an if true here so that my indentation is correct. Oh. doesn't have a view? Oh, it's because I called that. That's the correct place. Oh, yeah, that'll mess things up. What did I name it? I feel like I've done this a million times now and I keep just having to retype it. Oh, I just did jump variable. No, that's not what I wanted actually. Come on, where's my stack? Here it is, next jump. Next jump. And then it was what? Next jump value. Ugh. Oh, I messed it up. Okay, you know what? I'm just gonna fucking copy it. 40CEEA. Since we had it earlier, I just don't feel like copying and pasting things right now. Okay, so we have that. Let's see if it works now. Nope. Could not assemble. Looks really weird. Did I get it? It's supposed to be a byte thing again. Oh, I didn't do this. Oh my gosh. There we go. All right. So now it worked. And let's see. I gotta go in just a couple minutes. If we take all of this and get rid of all this extra space so that I can copy and paste the whole thing in. Let's see what happens. Let's fix that first. All right. Hey, that actually, no syntax errors. All right. And if we do a unret current basic block, do we get another one? No. Register value has no add. God damn it. What line was that on? Line 6. 2, 3, 4, 5, 6. get red value at. No, that shouldn't be right. Maybe the red address is wrong. Oh, no. That's what. All of my mistakes that I made in the there we go. Haha. So we now have a nice little function that will automatically deobfuscate the returns. So do it again. Nope. No variable. Var data. Get SSA var definition. Oh, I messed it up again. All right. There we go. So I have to go, but next time we'll take this and we'll automate it further so that it'll just keep doing it over and over and over again, as well as we'll figure out how to do that jump, and then we'll see what other weirdness we can find in here. So thanks to those that were hanging out with me. I know it was kind of a small crowd tonight, but still hope you had some fun. So yeah, I'll see you guys later.